Hello, friends. My name is Timen, and I'm a chemistry tutor at eLearn. Today, we are looking at writing chemical formulas for ionic compounds. However, before we do that, we need to understand what a chemical formula is. A chemical formula is a combination of chemical symbols and numbers used to represent an element or compound. Chemical symbols for all elements are listed in the periodic table. In most chemistry exams, they provide you with a copy of the periodic table, usually at the back. For most elements, the chemical symbol is adequate to represent the element, but there are some compounds in which, elements in which a chemical symbol has to be used. These are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They are referred to as diatomic elements. As you can see for hydrogen, we have H to represent the element and the number 2 as a subscript to show that each molecule of hydrogen has 2 atoms. Now, when we go to writing formula for ionic compounds, we have to recognize that the compound we are dealing with is an ionic compound. An ionic compound contains a metal and a non-metal, while a covalent compound contains non-metals only. So as a rule of thumb, if you have a compound that does not contain a metal at all, then that substance is not an ionic compound. We use the periodic table to see if our element is a metal or a non-metal. Non-metals are on the left-hand side of the periodic table. There is a step that we normally write, and I have a periodic table here in outline to help you find your metals and non-metals in the periodic table. The step here is in red, and the non-metals are on the right-hand side, and all metals are shaded here in blue. Now, we want to start with a simple binary ionic compound. Binary simply means there are 2 elements in the compound. There are 4 steps that we need to follow to write the formula of an ionic compound. Step 1, we write the symbols of the elements. Now, you need to recognize that non-metals that end with IDE simply shows that it is just a non-metal rather than polyatomic ions that we are going to talk about later. Step 2, we write the valency of each element. We can use the periodic table to help us find the valency. And valency is simply a combining number which tells us the number of electrons that an atom loses or gains in order to have a full outer shell. Step 3, we draw arrows to crisscross the valencies. I'll show you how to do this in a moment. And the last step, we write down our formula and we simplify the formula if necessary. So using the periodic table to find valencies, we just start with group 1. All these elements in group 1 have a valency of 1. This simply means that they lose 1 electron to get a full outer shell. We go to group 2. The elements in group 2, all of them have a valency of 2. Again, these ones are losing 2 electrons to get a full outer shell. For group 3, more or less the same thing. The valency is 3. For group 4, the valency is 4, but here we usually talk about the ones at the top. The moment we get to tin and lead, the story becomes a little bit more complex than we want to talk about here and now. For group 5, the valency now is 3. These are gaining 3 electrons to get the full outer shell. Group 6, the valency is 2, and group 7, the valency is 1. So what you do to your periodic table when you are in an exam is to write the valencies across as follows, or as shown in the diagram there: 1, 2, 3, 4, 3, 2, 1. And that is going to help you with answering any formula writing questions. So we are going to start off with an example. I just like this one that everybody kind of knows: sodium chloride. So the first thing that we do is we write the symbols of the elements. Step 1, chloride ends with IDE, and this means it's just the element. And then after that, we are going to write the valencies of the elements. I'm bringing in a section of the periodic table to find sodium. And here is my sodium, which is in group 1. Therefore, the valence is 1. I write down 1. And then I move over to chlorine, and then I bring a section of the periodic table here. Look for my chlorine. There is chlorine. It's in group 7. And again, the valency is 1. So I put down 1. After that, I crisscross the valencies. Sodium points to the valency for chlorine, and chlorine points to the valency of sodium. And then I use these numbers to write the formula. So notice the number now that I have for sodium is 1, which was the valency of chlorine. And the number that I have for chlorine is also 1 in this case, which was the valency for sodium. Now I simplify and get my formula, which is NaCl. Let's look at another example. Here we want to look at magnesium fluoride. We follow the same steps. First thing, we write the symbols of the elements. Next, we need to write down the valencies. We bring in the periodic table, look for Mr. Magnesium, and there is magnesium. Magnesium is in group 2. Therefore, the valency is 2. So I write down the 2 just under the magnesium. And then I bring again the periodic table, look for fluorine. There is fluorine. The valency is 1. And then I put down the 1. I crisscross the valencies, and then I write down the formula for magnesium fluoride, which is going to be MgF2. I simplify, like I've said before. Here it means just taking off the 1. We don't need to show the 1. Okay, let's look at more examples. First one is calcium sulfide. We do the same thing. I'm not bringing the periodic table now. So I start symbol for calcium, Ca, symbol for sulfide, S, and then I bring down the valencies. Calcium valency is 2, sulfur valence is 2. Calcium is in group 2, sulfur is in group 6. I crisscross the valencies, and then I get Ca2S2. And because I have 2, 2 there, I simplify, and then I get my formula as CaS. One more example. Aluminium oxide. We are going to follow the same steps. First thing, we write the symbols for the elements. For aluminium, the symbol is Al. For oxide, which is oxygen, the symbol is On. I put down the valencies. Aluminium is in group 3, so the valence is 3. Oxygen is in group 6, so the valence is 2. I crisscross the valencies. And then after that, I write down the formula Al2O3. This one does not need to be simplified, still going to be Al2O3. Few more examples for you. Lithium iodide. So lithium iodide, put down the symbols as before. Li and I, valencies are 1 for both. And then I crisscross, write down my formula, Li1 and I1. 1 and 1 disappears, and then my formula is simply going to be Lii. Potassium phosphide, same drill. The symbols, the valencies, crisscross, write down the formula, K3P1, simplify, and then I get my formula as K3P. We move on, but now I'm going to give you a few for you to do. You can pause the video at this point so that you can work them out yourself. I have the formulas here. Okay, good. So we are done with the first simple binary ionic compounds. Now we want to move on to ionic compounds that have polyatomic ions. Now, we still follow the same 4 steps. The only small difference is instead of writing the symbol for the non-metal, now we have to write the formula for the polyatomic ion. A polyatomic ion is an ion that contains many atoms. Step 2, we put down the valencies of the metal and the polyatomic ion. Step 3, the arrows to crisscross. And then step 4, we write the formula, we simplify it if necessary, and something new, we use brackets as well if necessary. So we have a few polyatomic ions that we are required to learn. You are not going to find this in a periodic table, so these you have to memorize. I have a few here, there are a few more, but if you learn just these ones, you will be able to write formulae for most ionic compounds that you're going to come across. I have ammonium carbonate, hydrogen carbonate, hydroxide, nitrate, phosphate, and sulfate. These are the most important ones, and then you just have to learn this off memory because you are not going to be provided with these ones in the exam. So let's look at a few examples. Calcium sulfate. Now, this one is not sulfur because it doesn't end with IDE. It ends with ATE. Now, this tells us that it is a polyatomic ion. So we write the formula first, Ca for calcium, SO4 for the sulfate. The valencies are 2, 2 for both. So we draw our arrows to crisscross the valencies, and then we write down the formula. Check the brackets that I have used around the sulfate part because the 2 is affecting both the oxygen and the sulfur. But because calcium and the sulfate have the same valencies, we simplify and then we get CaSO4. Another example is ammonium nitrate. We do the same thing. We write the formulae of the polyatomic ions. So for ammonium, it's NH4. For the nitrate, it's NO3. We put down the valencies that are coming from memory. Remember, no one is going to give you this in an exam in general. We do our arrows to crisscross, and then we write down the formula with brackets because they are necessary here, but we still simplify because it is necessary to simplify in this case. All right, so we have a few more examples, sodium hydroxide and potassium sulfate. So let's start with potassium hydroxide. So rather, sodium hydroxide, we put down the symbols, NaOH, valencies 1, 1, crisscross, and then our formula is NaOH. The OH is in brackets with the 1, but because we simplify, the brackets disappear. Potassium sulfate, the symbols K for potassium, SO4 for sulfate, and we put down the valencies. We crisscross as before. We write the formula, and K2SO4, and then the sulfate has a 1 in brackets. The 1 and the brackets disappear. Right, a few for you to do. You can pause the video again. I'm sure you're getting an idea of what's going on there. There's a mistake there that you need to fix for magnesium hydrogen carbonate. So we move on. Now we want to look at ionic compounds with transition metals. We follow the same steps, 4 of them. Same thing as before. The difference is just in step 2, because for transition elements, the valency of the metal is provided in Roman numerals. I'm going to show you just now what that means. And then we draw the arrows as before, and then we write the formula again as before. So let's start with examples. Iron 3 oxide. So that 3 in Roman numerals is telling us the valency of iron. We write the symbol. We put down the valencies, check the valency of iron is 3, as given in the Roman numerals. We crisscross, and then we write down our formula. No need to simplify in this case. So our formula is Fe2O3 for iron 3 oxide. We go to copper 1 sulfide, put down the symbols. We have copper, which is Cu, and then we have sulfide, check IDE at the end. So this one is simply S. Our valencies are 1 for copper, 2 for sulfur. We crisscross, and then we have our formula Cu2S1. The 1 disappears, and then we have our final formula for copper 1 sulfide as Cu2S. So we move on. We look at a few more examples. Cobalt 2 hydroxide, CO, OH, the valence is down. For cobalt, it's 2. As per the Roman numerals, the hydroxide is 1. You memorize this one already. We crisscross valences. We write down the formula. We need brackets for the OH. The 1 disappears, and then we have our correct formula there at the bottom for cobalt 2 hydroxide. Another example, copper 2 sulfate. This one is very common. Cu for copper, SO4 for sulfate. The valences are 2 for both. We crisscross, write down the formula, simplify, remove the brackets, remove the numbers. For you to do, you have a few iron 2 chloride. You can pause the video now. here are the answers.